Now he's got that foot on there. He used the hot torch to build up a little additional heat and a pair of shears to allow him to refine the form of that foot. So he's going in, it looks like he's crimping in some little toes, which is perfect because our pumpkin man has exposed feet and hands in the design. Now there's a lot of ways to make sculpture out of glass. Today we're kind of combining both hollow sculpture and solid sculpture. So the pants on this fella are essentially made out of a bubble of glass that's been manipulated and changed to define each pant leg. And then the feet are being added on as solid bits of glass. So we can really see the definition in that foot now. And here comes the next one. Now, whenever we're sticking two pieces of glass together, we need those materials to both be hot enough so that they create a nice firm seal. If you stick a piece of glass on and it's not quite hot enough, it has the potential to fall off later on in the making process. So these two will be making sure that everything is nice and warm so that it's all creating a firm, permanent bond to one another. But here we go, some more trimming and toe work on this next foot. And again, especially to those of you just joining us, if you have any questions throughout the demonstration, please feel free to get my attention. I'd love to answer them for you. Now, the view that we have inside of our reheating furnace isn't due to a special high-fire camera, but instead it's due to a very neat piece of glass seated in the back of that furnace. That glass is called fused silica. It's a different type of glass than what we're melting here today. Its only ingredient is that silica sand, and that melts at around 4,000 degrees Fahrenheit, which allows us to see inside of that reheating furnace. There are several different types of glass, and they all have different properties. The material we're working with here in the studio is designed to stay hot for a long period of time, allowing us to do all of these little manipulations to change the surface of the glass. But glass that we see in our daily lives, such as bottles and jars, things like that, that glass is designed on the other side of the spectrum. It's designed to set up very quickly so it can be made through an automated process. There's even more other different types of glass. There's borosilicate glass, which is designed to be able to go into our ovens and come back out so that we can set it onto a cool countertop without worrying about that material experiencing thermal shock. Now we have both of the feet on this. Looks like we're getting ready to add some more parts here. All right. So in order to continue sculpting the top portion of our pumpkin man, Helen is preparing a punty for George. And punties are temporary handles that will apply to the bottoms of sculptures or vessels in order to be able to access the other half of that design. So this will get stuck right onto our pumpkin man's feet so that they can continue sculpting the top half of his body. Now, I'll point out there is a little constriction that separates the pumpkin man's body from the pipe that it's attached to. And that constriction will be a structural weak point where George will be able to break the glass free from the blowpipe in order to have access to that top portion. And that's a very important step. Just about everything we make in this studio gets one of those constrictions in it. And they're often called necklines or jacklines in reference to the metal tool that we use to create the constriction. But here we go. They're going to apply this puntee right to the bottoms of his feet. They'll stick it on there. They'll take a moment to turn back and forth with one another to make sure everything's in a nice straight line relative to the pipe. And they're even going to crimp in a little constriction just below each foot, so they'll be able to take that puntee off when they're finished. Now a few drops of water along the neckline and a light tap is all it takes to break it free. Now at the beginning of your glassmaking career, transferring over objects like this is really tricky. It tends to be where you tend to fail the most. If that connection to the bottom of whatever you're making is too cold and you go to break it free from the pipe it's attached to, it has the potential to release simultaneously from both irons. Then whatever you're making will crash down onto the ground and typically break into a bunch of pieces. So that's something that can be really hard to get the hang of. Glass as a material is pretty tricky to work with initially, not only because you're looking at a lot of strange new muscle memories, such as rotating a pipe, but also you have to learn a lot about the material itself. If it gets too cold at certain stages, it'll crack and break. If it gets too hot at other stages, it has the potential to crumple up on itself. So it's a pretty tricky thing to work with. Now, we do have a lot of experience down here on the team today. George has been working with glass for over 30 years at this point, and Helen's been working with glass for over 20 years. So they're going to make a lot of this process look pretty effortless. And that's just because they have all of those skills I was talking about kind of as a second nature at this point. Yeah, we have a question from online. How long does it take to become a master glass blower? And I'll tell you, just about any glass blower will say you're kind of a student for life with this material. Anytime you try something new, you have kind of a higher fail rate because it's something you've never done before. But we do say it takes between 3 to 6 years to become a proficient beginner with this material. And that's just because you're looking at all of those finicky new things to learn. How to keep the pipe turning so that whatever you're making stays straight and on center. How to know when to go in and heat up your glass so that it won't potentially experience that thermal shock. And then you also have to know the limits of when you're heating it too cold, when you're heating it too hot. And that can be very different depending on what you're making. When you're making sculptural work, you'll tend to work a little on the cold side so that you don't lose tiny little details on whatever you're making. But if you're making blown work, especially something as finicky as goblet making, then you have to work very quick and very hot because the walls of your bubble will be very thin, so they'll cool down very quickly every time you come out of the heat. So there's a lot that goes into this medium. Now to check back in with what our team's been doing, George has been kind of separating the bottom half of this from the top half, setting up his proportions for the body of our pumpkin man. Helen has collected a little clear glass and is layering some of that black frit right onto the top of it. Now every time you layer frit onto your clear glass, you have to go back to a reheating furnace and melt all of that material nice and smooth. Now, while George is waiting for Helen's bit to be hot and ready to add onto his base form, he has to continuously return to the reheating furnace in order to keep that base nice and warm. So he's kind of in a holding pattern right now. This torch that he's using to keep the puntee warm, we call it a fluffy torch, and it's essentially propane with air flowing through it to make it a little hotter. And that can be used as an auxiliary heat source. But here we go, it looks like we're adding some arms onto our pumpkin man. And this is a very similar way that you would add a handle onto a vessel. So he pushed that bit of glass down onto the body of the form and then stretched it out to set the diameter. Right now he's using a pair of tweezers to set up the elbow of our pumpkin man. And he can go in with a hot torch to really help refine those details. Yeah, so we have a question about the type of punty we're using right now and how it's able to hold up the mass of the character that it's attached to. Now, the punty arms are kind of thin looking, and it's able to support the weight of that character because George just isn't getting it hot enough for those little tongs to bend and wobble around. So it's also very well adhered to the bottom of his feet. It's actually what we call a sculpture punty, meaning it's a full fuse onto the object. And that can be utilized quite a bit in order to make things like this. And this particular style of punty is called a prong punty. You'll see it used especially for figurative work where you have someone's feet so that you can have a hold of it without needing to make a base for that character to stand on. And here we go with another arm. George pushes it down onto the character, stretches it up to set the diameter of the arm, crimps it, and then cuts it free. Now, the type of shears that George used to cut that arm free are called diamond shears. And they're one of my favorite tools that we have available. They're not quite like the shears that we see in our everyday lives. They're called diamond shears because they cut on 4 planes. So they make kind of a diamond cross section when you use them. This is especially handy when you're making glass sculpture because you can cut it down to a very fine point rather than leaving a very long, sharp edge. Here we go. He just removed a little excess material on that new arm. He's refining it, getting it into a nice shape. Now, based on what we've seen so far, I expect probably we'll see some hands being formed next. It looks like Helen's picked up some additional color, so I think that that's accurate. Now, there can be all sorts of different ways to design glass. I know our pumpkin man has like an insignia on his chest, I believe. Yeah, he's got a little pumpkin right on his chest. So we'll probably see George also utilizing the use of stringers to draw directly onto the pumpkin man's body to create all of those little details. So while George is waiting for Helen to bring over the next parts, I'd like to point out how diligent he is about checking in with that pumpkin man. Every time he takes a reheat, he comes back out and makes sure that everything is still in the exact same spot that he had it in before he went over to the reheating furnace. And that's really key, especially when you're working with sculpture. With all of these little tiny parts, it's very easy to get them so hot that the pumpkin man's arm could potentially wave around and get knocked out of alignment with where it needs to go. So every time he takes a heat, he comes back out, makes sure it's all sitting exactly where he needs it to be. But here we go, another hand coming over. He'll stick it on, making sure it has a very nice connection to the arm, and then he'll stretch it up and cut it free. Now right away he'll begin to shape that hand, making sure that it's in exactly the right proportions to the rest of the body. He'll also create little details in it, separating the wrist from the jacket of the pumpkin head. Now, of course, as soon as you cut the glass free that Helen brings over, it has a cold spot where it was cut. So she has to return immediately to the heat in order to be able to add on the next part. If you try to add it on immediately after cutting the glass, it can be too cold, and then it could make not as good of a connection. Now, the orange that they're adding on is made out of a cadmium-based glass. Cadmium and selenium, I believe. And here we go with some little fingers being added onto that hand. Now, especially at this point where you have all of those little fingers separated, you don't want to get it too hot, or the little fingers will curl right up on themselves. So this is really the point where when you're working with sculpture, you have to be very careful about just how hot you're getting it. Here comes the next hand. It goes on just as a little blob, and then it's all up to George to change that from a blob into a defined hand. Now, more and more, this character is looking quite a bit like a headless horseman right now. But I think after we get these hands all settled in where they need to go, they'll be working on our pumpkin head next. Yeah, can you talk real loud for me? Sorry, I can't quite hear you. I'm gonna pop out.
Can you pick up a chunk of that orange, Helen? Just kind of low bite.
Yeah, what's the difference with all the ovens that Helen's been dipping into? So we have a garage unit over on the far side of the stage, and that holds the glass at around 900 degrees Fahrenheit. So they have all of the colored glass that Helen's been bringing over to George located in that garage unit. So that's one of the ovens. The other one is another reheating furnace that is at around 2100 degrees Fahrenheit. Now, a nice thing about having a second reheating furnace is that it allows you to be able to prepare all of those little bits to add onto the glass without needing to crowd George in the reheating furnace that he's using. So you'll see that a lot in a variety of different settings, especially production glassmaking. They'll often have two furnaces running, one to kind of start the project, and then another one to be able to finish it off. Yeah, what is the COE of the glass we're working with? That's a question from online. And this one is 96. That's pretty standard for furnace working, but the COE is in reference to the coefficient of expansion. That's how much the glass shrinks as it cools down and expands as it heats up. And it can come in a wide variety of ranges. Borosilicate glass has a COE of 33. It's what we call a stiff glass, meaning it doesn't shrink very much at all as it cools down. Our glass is kind of a middle ground, the 96 COE. It's a pretty soft glass. But you can also get glass that's even softer than this with a coefficient of expansion of 104. That's typically used for bead making. So George really has the body of this fella pretty well defined, and Helen has picked up a little piece of orange glass on the end of a hollow stainless steel rod. And we believe that this will be for the head of our pumpkin man. And because it's on a blowpipe, we know that the head will be formed out of a bubble of glass. So there's really two options for sculpting with glass. You can either form everything out of bubbles that you shape into intricate shapes, or you can do what we call solid sculpture, where you're working with the glass very similarly to the way you would work with ceramics or Play-Doh, where you can create each individual part of the object you're making out of solid glass, stick all of those parts together just by heating up the ends and touching them together. A really neat thing about glass is that it acts as its own glue as long as you get it hot enough. There we go, a really nice view of our pumpkin man. He looks really spooky to me so far. So now these two have traded pipes. George is going to be getting that colored glass into a nice, agreeable shape to be able to collect more clear glass over the top of it. And what I mean by that is he essentially is shaping it into like a Q-tip shape. And what this does is allows him to plunge that glass below the surface of our molten glass that we have in our melting furnace without the risk of trapping any air bubbles between those two materials. If you have any form of undercuts or a flat surface on the top of your glass, you go in to collect more out of the furnace, you're going to tend to trap little bubbles of air just from the shape that it was in before you go in. Sometimes this can be a design element if you want to create a design of bubbles, like in this bowl right here, then you'll intentionally go in and create little dimples. But now George has a layer of clear glass over the top of that orange. He went into our melting furnace, plunged that orange glass below the surface of the molten glass, and then turned in one direction to wind that material on. Meanwhile, Helen's doing what we call babysitting in the glass studio. She's keeping our figure nice and warm so that it's not going to crack and break, but cool enough that it's not going to warp or change in form. Now George has inflated that glass a little bit. He used a flexible pad to shape the glass. That pad is made out of newspaper, believe it or not. And the key to using a newspaper pad like that is to keep that pad of paper nice and wet, saturated with water. By doing this, when you make contact with that molten glass, the water will turn to steam and create a protective buffer between both materials. This prevents the newspaper from sticking to the surface of your glass and allows it to glide along. He's also plunged this bubble down into an optic mold, very similar to this one I'm holding up right here to give you an idea of what the inside of those look like. By pushing the glass down into those optic molds and then inflating the bubble while you're inside of them, you create ridges in the surface of the glass. Now we'll use those molds quite a bit this time of year to create all of our pumpkins that you'll see around. It gives them those beautiful ridges. And actually, George has the world record for the largest glass pumpkin ever made. If you're here with us in person today, I encourage you to check it out. It's on display right near the entrance in our truck that we have out by the entrance. And it's really big. It's so big we actually had to build an annealer to be able to fit it in and cool it down slowly. Here we go, we've got a nice sized pumpkin on the end of this pipe. So George created that constriction to separate the pumpkin head from the pipe. And now I'm just going to keep this warm for him while he checks in and sees what's going on. So I think we're going to be adding some details onto this. We need to give our pumpkin man a face here. So George is going to use that oxygen propane fueled torch to melt some glass rods that will allow him to draw right onto the surface of this head. So he's using a little string of glass and very carefully drawing out the eyes for this little jack-o'-lantern head. Now this can be a really tricky technique. If glass is hot and you touch it to another piece of hot glass, it's gonna stick. So you have to be really precise as you're drawing, because you can't really take it back. So we got those two eyes on. Now I have to take this over to the reheating furnace in order to prevent the body of the pumpkin from getting too cold. So now he's drawing on the mouth here. I think George must be a really good jack-o'-lantern carver, just based on what I'm seeing right now. All right. So now we have the outline of the eyes and the mouth on here. And now we're going to give him his little nose. So while George was drawing on the surface of that pumpkin, we had to hold the pipe steady for him. And in doing so, the object gets a little crooked on the pipe. So whenever I take it back over to that reheating furnace, my main goal is to try to just straighten everything back out so that it's not crooked. Are we going to be drilling a hole in the bottom of this? Okay. So to stick the head of this pumpkin onto our pumpkin man's body, we're going to add a little bit of glass right onto the base of his head, and this will function as a glue.
Okay, Alan, bring it over.
So George takes that, drips it right onto the pumpkin head. Now he'll stick that right onto the body of our pumpkin, and he'll crimp the constriction at the top of the head to weaken it. And a little tap is all it takes to break it off. Now right away, Helen has to go and heat that up. We want to make sure that that head is really well stuck on there, but also that nothing's getting too cold.
No, I'm going to do a
So now we want to cover up that opening at the top of our pumpkin, and we're going to be adding a little stem to it, very similar to the stems you'll see in the pumpkins all over the place right now. So Helen's preparing that stem. She collected some clear glass out of the furnace, and she's added on a green color to the surface of that clear glass. She'll end up going into a mold very similar to the one that George used for the ridges on the pumpkin head to create some texture on that stem. And then she'll bring it over and they'll stick it onto the head and create some darling little curly cues. So into the mold she goes. George will take the pipe, guide it to where he needs that stem to stick. They'll stretch it out. Turning it will create some spirals in the texture they applied. And now just a quick wrap around a copper stick will give it that darling little curly cue. And right away, George can stick that onto the pumpkin head right where he wants it to go. Now that's a really tricky thing to do, especially when you first start off. It's kind of like trying to sculpt something out of a hot noodle. It's just flailing around on you. And you want to make sure that you grab it and stick it where it needs to go right away. Because if it sticks itself down onto the pumpkin, well, it's going to be stuck there, no matter what you want. But I think that's pretty adorable. What do you all think? Yeah. Alright, so I believe that George is going to do a little extra for this design. They're kind of discussing how to move forward here. And I believe he's going to be making a pumpkin in order to seat this figure on top of. So it'll be a pumpkin man with his pumpkin stand. Yeah, we have a question up there. Can you talk real loud? About how much does that weigh? Only a couple of pounds, something that size, yeah. And you have to remember the body of the pumpkin man and his head are both hollow. Now, if this were made out of solid glass, it would be quite a bit heavier. You would see George sweating quite a bit more, too. So they've stored our pumpkin man in our garage unit over here. And this can be very useful when you're making sculptural items. It keeps the glass at a temperature where you can reintroduce it to the heat safely without worrying about it cracking and breaking, but also keeps it cold enough that that shape isn't going to warp and change while it's sitting in the garage unit. Meanwhile, Helen's making what we call a collar out of clear glass, and we'll use those collars often to be able to stick colored glass right onto the top of our blowpipe. So it essentially acts as a little bit of glue so that you can stick the color right onto the surface of your blowpipe. So we have a question about the name of the two-style prong punty, and that's just exactly what it's called, is a prong punty. They can be added as sculpture punties, where you adhere them firmly to the bottom of things. That's typically how they're utilized. But they can also be added so that they can be just a temporary holder, where you can remove it easily at the end. But punties can be all sorts of different things. You can have prong punties, sculpture punties. You can even have punties that are essentially a plate of glass that you stick onto the bottom of an open bubble so that you can open up the other end of that bubble. There's really a lot of different ways to transfer glass from one pipe to another. and it all just depends on what you're doing for what type of punty you use. The most standard is a very easily removable punty, and it's just shaped like a little Q-tip so that you can control how much of it you smush onto the bottom of whatever you're making, and you make it so that it has a very weak connection point, allowing you to easily remove whatever you're making at the end of the process. You'll typically see that one most often for your standard blown vessels, so that you can take it off without having to cold work and grind away a punty later on. Here we go. George is setting up to make a really large pumpkin. He's pushing over a nice large mold to use. Helen is heating up the color for that pumpkin, really getting it all adhered to that clear collar of glass that she made. Yeah. How often do we change our newspaper pads? Yeah. So the newspaper pad will tend to last a couple of days, really. And the big thing with the newspaper pad is that you're constantly re-wetting a paper-based product. So they'll get really mushy after a few days and just kind of fall apart on themselves. But we get asked quite a bit about whether or not we can feel the heat through that pad. And we make them thick enough that you really can't feel the heat at all. It's very comfortable to use. The thing that's really annoying about that pad is when they're fresh, they really smoke up, it makes you cry a little bit. But also, every now and then, a little cinder will fly off and tag your forearm. And especially with wearing masks, that can be a nuisance because you have to then swat it like a mosquito. Whereas a year ago, you could simply blow on your arm and that cinder would fly away. So that's also one of the more common ways that we get a tiny little burn every now and then. All right, so we have our orange color on the pipe here. They're getting that all shaped up to be able to go in and gather some glass out of our melting furnace. So you can see that shape I was talking about, a nice Q-tip form on the end of the pipe. And that'll just prevent any pockets of air from getting trapped when he dives down into the clear glass here in just a moment. Now, before he goes in to collect that clear glass, he'll actually allow this glass to cool down a little bit. And in doing so, he'll prevent it from warping and changing when he goes into that oven. But also, our clear glass at 2,100 degrees Fahrenheit moves and flows just like warm honey. So if you go into that glass with something that's already hot and moving and flowing, it's not going to support the weight of more material and has a high likelihood of just falling off into the furnace. So especially when we're working with colored glass, we'll allow that to cool down quite a bit before we go in and collect clear glass. But even if you're working in only clear glass, you'll allow your starter bubble to really cool down and get nice and rigid, so that when you go back into the furnace and collect more glass over the top of it, you don't have the chance of it just falling off the pipe or potentially twisting and warping up. Because if it does twist up in the process of gathering, then that can cause you to have really uneven wall thicknesses throughout your vessel that you're making. Yeah. Yeah. Yeah, so sometimes we will wear a sleeve over our forearms, but usually it's not to protect us from the newspaper pad specifically, but to protect us from the radiant heat of whatever we're making. So if we're making something really large, especially really large bowls, the radiant heat tends to go right onto your forearm, whether that's when you're putting the constriction in to separate what you're making from the blowpipe, or especially when you're opening up the vessel. Because when you open vessels, they start off with really narrow openings, and you have to use the blades of the jacks to push that opening further and further until it gets to the point where you want to stop. So you can imagine having your arm this close to a 2,000-degree bowl in a parabolic shape is really going to radiate heat onto your forearm. So you can use those sleeves to protect your skin, but also glass blowers, we all kind of know when each other are getting toasty. There's a few things that you can see. When someone's pinky goes out, that's usually a sign that their hand's getting pretty hot. And we have these large wooden boards that we can use to protect each other, sneaking in between the arm and the object to be able to save each other from that heat. So this is really a team sport, regardless of what you're making. It can be really useful to just have someone around to be able to help you in that way. Yeah. Sorry? Yeah, when we use gloves, it'll often be for like large sculptural things. Most often, you'll see someone wearing a left-handed glove if they're turning a pipe for something really big. You want to be able to choke up on the weight of that pipe as much as possible. So having a glove in that instance can be pretty handy. Or if you were doing a lot of detailed work, like we saw George drawing with stringers on that pumpkin. Now the pumpkin for that was pretty small. He didn't need a glove for that, but if it had been double the size, he would have thrown on a pair of leather gloves to protect his fingers while he was that close. So we're preparing to transfer this fella over to another rod here. This will allow us to stick him onto his base a little easier. All right. So in order to control the thermal shock, to get that to break on both of the connections to our punty, I held a couple of pair of shears on each side while George tapped the pipe, and that helped tell the glass exactly where we needed it to break. But we've transferred him over because we want to seat him feet down on the pumpkin he'll be sitting on. So we're just thinking several steps ahead here. And that's something that you always have to do when you're working with glass. We get asked quite a bit whether or not we know what we're making before we start making it. And the answer is, well, yes, it's kind of like playing chess. If you don't know the next move you're going to be making, then your opponent, or in this case, the glass, is going to win. So now before we get started on making the base for this fella, they really want to make sure that everything is in just the right shape so that when we go to stick him on the base, it'll all go very smoothly. So it looks like he's adjusting his position to make him kind of seated. And then off into the garage he'll go. So right now, George is warming back up that orange glass on our blowpipe that we had prepared a moment ago. And he'll get that all ready to gather over here in just a moment. Now, as he waits for that to cool down, it's a good opportunity to get your tool bench organized. And then in he'll go. So he plunges that colored glass below the surface of the molten glass in here, rotating smoothly in one direction, and comes out with about double the material that he started off with initially. Right now, he's going to use a cherry wood scoop tool called a block to evenly distribute that fresh layer of glass around that core colored glass. Now, these wooden blocks last a couple of years in a glass studio because you keep them saturated with water, both to preserve the lifespan of that block, but also so that it doesn't stick to the glass itself. So we have a question from online about what prevents the glass from turning into a puddle in our annealing ovens. Now, for those of you that don't know what an annealing oven is, at the end of every project that we make, we have to allow the glass to cool down very slowly in a controlled environment. So we put them into large kilns that are programmed to very gradually come down to room temperature. The length of that time really depends on the thickness of the glass. Now, what prevents it from turning into a puddle in the annealer is kind of two things. One, it's the control on the annealer, keeping it at just the right temperature so the glass isn't moving and flowing, but it's also still warm enough that it's not cracking and breaking. But also the length of time that you keep it in that annealer. If you kept it in the annealer at 900 degrees for several days, that glass would begin to warp and change a little bit over time. But they only stay in the oven at that temperature for a few hours, typically throughout our workday, and then it'll very slowly come down to room temperature overnight. And that really depends on what we've been making throughout the day. If we've been making all paperweights all day long, we won't see those come out until a couple of days later, because it can take up to 24 hours to relieve the stress in a softball-sized paperweight. For blown objects that are very thin, such as ornaments, it could take only 8 hours to cool down to room temperature. So it's all just about the thickness of the glass itself. But here we go. George allowed that previous layer to cool down and went in and collected another one. And you can see how pretty quickly you can get quite a bit of glass on the end of a pipe just by going back in and collecting more and more. Right away again, he'll shape, cool, and center that glass using a cherry wood scoop tool. And those tools come in a gradient of sizes. They can be very small for making very small objects, and they can get up to sizes that are bigger than my head to shape really large quantities of glass. This one's a nice medium size. But now he's hooking up a blow hose to the mouthpiece of that pipe, and that hose is hooked up to an air compressor system, which is controlled by a foot pedal. This was our solution to be able to continue doing these demonstrations while we have masks on. So it takes our mouths out of the glass blowing equation. Now, a nice thing about working with colored glass that's right on the blowpipe is that essentially is where the bubble is at in this material. So as you watch that colored bit of glass in the middle expand and grow, you're actually seeing the bubble itself expanding and growing in the glass. Are you gathering again, George? Yeah? Oh boy. So George has cooled this down. He's going to go in for another layer of glass. So this is going to be a really big pumpkin. So we have a question from online. Is there any particular reason why the blocks are made from cherry wood? The blocks could be made from pretty much any fruit wood. And what's really nice about fruit woods for those tools is they have a really nice, dense grain pattern that allows them to burn out nice and evenly. You're not going to run into a spot that turns into a hump as you're shaping that molten glass. But also they have a very low resin content, which prevents it from creating like a scuzz on the surface of the glass as you're using it. So fruit woods are just uniquely suited for working with glass. We use cherry wood quite a bit in America, and I believe it's just because we have more of it readily available. Why don't you get burned when you're touching the newspaper to the glass? Well, the newspaper pad is made out of more than one sheet of newspaper. That's really the key to that part. And depending on what you're making, you can make a newspaper pad that's a little on the thinner side or a little on the thicker side. If you're going to be making really big work, like this pumpkin that we're working on right now, you'll want a paper pad that's a little thicker so that that radiant heat isn't getting through to your palm. But if you're making very delicate work that you really want to be able to shape with your fingers, say, you'll want a thinner pad so that you can really change and affect that pad with just the motion of your hand. So the answer is it kind of varies. For this one, it's thick enough that George's hand is nice and comfortable. So George has inflated this quite a bit, and now he's building up a lot of heat on here. He may be going into the optic mold next. We'll have to see. So he plunges it down into the mold, really pressing the glass into it. He'll even inflate it while he's in there, blowing pretty strong. And that pushes the sides of that bubble into all of the ridges inside of the mold. For those of you that weren't here with us earlier, here's what the interior of those molds look like. So when you press the glass down into it, it really takes on the texture from the mold. Now we call these optic molds because they change the optical qualities of the glass, the way the light will radiate through it. It's not a finishing mold, however. This could still be a wide range of different things. We know that George is making a pumpkin with this particular one, but it could also be a vase or a bowl or pretty much anything that you could imagine could be made using that pattern. You could also choose to change the pattern coming out of these molds. You could leave it straight the way it is on pumpkins. You could pinch the ridges of the mold together to create different designs. You could also twist up the ridges. So it's really just up to the gaffer and what they have in mind. Right now, George is cutting in a neckline on our pumpkin. And I'm just sneaking in and protecting his knuckles a little bit. Using gravity, tilting that pumpkin down towards the ground. And we really want to get this constriction nice and tight so that when we go to break this pumpkin free, it doesn't have a chance to break where we don't want it to. So now George is using a wooden paddle to push in a little bottom to the pumpkin. This will allow it to sit nice and flat on whatever surface it gets displayed on, in Nathan's home probably. And now we're going to transfer this very large pumpkin over onto a secondary iron in order to gain access to the opening of the pumpkin, where we'll add a beautiful stem onto it. So Helen's preparing that punty. And if you're curious about how we're able to hold on to these pipes, which are preheated, well, they're made out of stainless steel, which is a relatively poor conductor of heat. But also we have that water feature Helen just used to cool down the handle of the pipe. And that'll allow her to really be able to choke up on the weight of the pipe, creating a usable fulcrum so that she can really handle that pumpkin easily. So she's rolling the glass on the steel table here. This is actually a tool called a marver. And what she's doing is weakening the strength that the connection to the pumpkin will have. This will allow them to be able to remove the pumpkin when they're all finished from the pipe pretty easily. So George sticks it on there. He's going to use some water to create thermal shock along the neckline of the pumpkin. And a tap is all it takes to break it off. So now we have access to an opening on the top of the pumpkin. If we were making a bowl or a vase out of this form, that would be what we stretched open to be the rim of the vessel. But for this, we'll end up plugging it up, I suspect. It seems Helen's getting ready with the figure. So I'm going to begin preparing the stem for George here. So just like on our pumpkin man's head, this is going to be a green stem. So I'm going to roll it through that green frit here to apply a little bit to the surface of the clear glass. So we'll stick it on, he stretches it out. And then cuts it free. And this one will just be kind of a traditional pumpkin stem like you'd see in the grocery store. No need for any fancy curlicues. We already have that on our pumpkin man's head. Now, to get rid of the sharp area where it was cut free, he's using that oxygen propane fueled torch again. So I'm just watching the team right now, making sure that when they need me, I'm able to jump in. We've got to get our timing just right between both of these two benches. We'll end up adding a little bit of clear glass onto the pumpkin to act as glue to keep our pumpkin man attached to it. So really what I'm looking for is George to look at me and give me a nod.
You flash and bring it over once, Helen.
They're gonna do a little size check to see where they're gonna seat the pumpkin man. Are you ready for that now, George? All right. So I'm gonna grab that glass that we're gonna stick the glass onto the pumpkin man and then stick the pumpkin man onto the pumpkin. And George is preparing to be able to remove that punty when it's time, creating a weakness in it where it'll break off. Yep. So now I'll bring over some glass. He'll drip it right onto that pumpkin man. And there we have it. Our pumpkin man is now seated on his pumpkin. Are you good on doors? So to get rid of that unevenness where the punty was attached to the pumpkin man's head, he's using that torch to just smooth it out, melting away any sharp spots. Kind of pushing it down so it doesn't disrupt the texture on his head. Now, we had a question earlier about how much this object weighs, and I can tell you it probably weighs quite a bit more now than when it was just the pumpkin man. So now Helen is going to be suiting up, putting on some protective equipment so that she can carry this object into our annealing oven here in a moment. Before we do that, George will be equalizing all the temperatures here, making sure that everything's just right to be able to break off safely and put away into that oven. So a few drops of water onto that puntee connection to weaken it. Helen's ready to grab a hold of it. She's got some large Kevlar mitts on. A sharp tap to break it free, and now a little extra fire on the bottom to get rid of any sharp edges. And there we have it. Our contest-winning Pumpkin Man. All right, everyone, let's give it up for George and Helen. And thank you all so much for joining us here today, whether it's online or in person. We appreciate your participation. As a reminder, our next You Design It, We Make It is We've Got Spirit, Yes We Do, and it's to design your own mascot. The deadline for those submissions will be November 24th at 12 p.m. Eastern, and the demonstration will happen on November 28th. So get to drawing, make some awesome creative mascots and submit them in to us. We're so excited to see what you come up with. Thanks again, everyone, and have a great rest of your day.